So hello guys, welcome back to yet another video where today we'll be solving the second problem from the introductory problem set of CSES problem set. So let's get started. The question states that we have been given an array, let's name it as ARR, and inside that array we have all the numbers in the range of 1 to n except one number. That is, let's say according to the given input, the n value is equal to 5 and the array is equal to 2, 3, 1 and 5. Now, if I look all the numbers in the range of 1 to 5, they are 1, 2, 3, 4 and 5. I can clearly see that 4 is not present inside this array. So, my answer over here is going to be equal to 4. So, the problem states that we will be given an array and our task is to find the missing number in the range of 1 to n. So, how can we do this? The first way to solve this is by using the sorting algorithm. Now, if I sort the given ARR, what I will get is 1, 2, 3 and 5. I clearly know that n value is equal to 5 and the elements present over here are 4. So, if I start a for loop from I is equal to 0 and go all the way up till 4, since this is a 0 based index, or I can say that less than 4, what I will do is initially I will keep a counter, let's say CNT equal to 1. Once I sort this up, I will check if my ARR of I is equal to my count. If it is, then I will increment by my count value, and if it is not, I will directly say that this count is my answer. So let's just dry run this code. So initially for the given input array, which is 1, 2, 3 and 5, my I will be pointing over to here, which is 0, and this is going to be a 0 based indexing over here, and my initial value of count is going to be equal to 1. Now I will check, is my ARR of I equal to count? If yes, I will increment my count value. So I can see that 1 is indeed equal to 1. So I will increment my count from 0 to 1. Now I will see, and at the same time my count will also increment to 2. Is 2 equal to 2? Yes. I will again take my I pointer, which will go to index number 2, and my count will increment to 3. Is my 3 equal to 3? Yes. My I will also increase. I will go to index number 3 and my count will increment to 4. Now I can check that 5 is not equal to 4. So in that case, if it is a mismatch, what I will do is I will break from this for loop and I will return the value of my count. So over here we can see that the first step that we are doing is we are sorting this. Sorting takes a time complexity of O of n log n. Apart from that, we are also traversing in that array, which takes a time of O of n at the worst case scenario. And the space complexity is O of n since I am just using a count variable to check if the value is present or not. So with this approach, this is taking the time complexity of O of n log n plus O of n and a space complexity of O of 1. But can we optimize this? Can we reduce our time complexity to even a better value? Yes. So the answer is yes. So the second approach is by using the bit manipulation technique. So inside the bit manipulation, we have XOR operator. The property of XOR is all the similar elements, if I XOR them, the similar numbers when we XOR them, we get the value as 0. So how can we use this? So what we can do is, we can say initially our count value is equal to 0. Apart from that, one more property of XOR is, when I XOR any number with 0, I get the number itself. So if I start a for loop from I is equal to 1 all the way up till n, and if I XOR it with my count variable, then I will get something like this. If my count is equal to 0 and if I XOR it with all the values from 1 to n, that is 1, 2, 3, 4 and 5, I can say that count is going to be equal to 0 XOR 1, XOR 2, XOR 3, XOR 4, XOR 5. Now, if I again start a for loop from I is equal to 0 to 3, since 3 is the last index that is available to us, what I can say is my count is going to be equal to 0 XOR 1, XOR 2, XOR 3, XOR 4, XOR 5, which is the initial value of count that we have. And if you remember, now I am not sorting the array. So initial array given to us was 2, 3, 1 and 5. So this time if I start to XOR with the elements which is present in the ARR, I will get 5 XOR 2 when I start a for loop from I equal to 0, XOR 3, XOR 1, XOR 5. Now, if you remember the XOR property, it states that similar elements when XORed becomes equal to 0. So I can say this one and this one cancels out. Similarly, this 3 and this 3 cancels out. This 5 cancels out. This 2 cancels out. And we know 0 XOR 4 is a number itself, that is 4. So over here, since we have not done any sorting, we know that the time complexity over here is going to be O of n plus O of n, which is going to be 2 times of O of n, which is ultimately O of n. Space complexity again is going to be equal to O of 1 since I am also only using a count variable. So this is going to be O of 1. So what we can say is we have used the most optimized approach for this code, that is a time complexity of O of n and a space complexity of O of 1. So let's get to the coding part. This is going to be the code for the given problem. Over here we are taking the value n, which is going to be 5, and we are taking the input array over here, which was 2, 3, 1 and 5. Next, we have initialized the count variable which is equal to 0, and as I said, from 1 to n, what I will do is I will say count is equal to count XOR I. So that is what I am doing over here, and this is an O of n operation. Then what I am doing is I am traversing into that array and I am again doing count is equal to count XOR ARR of I. Once this is done, and this is also time complexity of O of n, this is I have just output the value of count, which is going to be my answer. So I hope you liked this video. If you did like, make sure to hit that like and subscribe button, and I'll be coming up with more videos. Until then, take care and bye bye.